Cisco Certified Network Associate Day 3. Welcome back. I'm Imran Rafa, your trainer for this entire series. As you know, this is a free training series provided on YouTube. And if you think this video has helped you, or if you think it could help a colleague of yours, please do not hesitate to share this video on your social media platforms. And of course, like this video. The more you like, the more YouTube would promote these videos and it would help a lot of people. In our last video, which is CCNA Day 2, we looked at OSI reference model and the TCP/IP reference model. In today's video, as you can see on the screen, we would be dealing with IP version 4. IP address and subnetting go hand in hand, and hence what I have done is break Day 3 into two parts. So I'll call this video Day 3 AM, and we will deal exclusively about IP address and its structures. And we will create another video called the Day 3 PM, and we will include subnetting in that video. Alright, without wasting much time, let us get straight into this. When we hear about IP address, and especially those people who do not understand IP address, we get scared and we wonder what these numbers really mean, and we most of the time really get worried because we don't understand the IP addresses. Well, trust me when I say this, IP address is a very easy concept to learn, and once you finish this video, you would be wondering what was it so difficult that you had to be really tense whenever you heard about IP addresses. And this, what you see on the screen, is nothing but an IP version 4 address. And as you know, IP version 6 has been released, and if you get scared looking at IP version 4 address, I would ask you to wait until you see IP version 6, an example of which is this. Well, don't worry, IP address is not that difficult. Once we understand the basics, IP addressing is very easy. Just because IP version 6 is coming, do not neglect IP version 4, because I think personally IP version 4 is going to be around for a very long time. And like you know, IP version 6 is included in the new syllabus of CCNA. So we would be dealing with IP version 6, but in a later video. For now, we would be dealing with only IP version 4. IP, as you know, is nothing but Internet Protocol, and IP version 4 is the 4th version of the protocol, and IP version 6 obviously is the 6th version and the latest version in the Internet Protocol. IP is a connectionless protocol. So IP, like you know from the last video, IP operates at layer 3. So the connectionless, and data sequencing and all these things happen on a layer 4 protocol called TCP, which we learned in the last video. Right, let's go down and look at IP4 in detail. Most of us have seen this screen. A Windows user would have seen a screen that's on your left, and a Mac user would have seen a screen that's on your right. This is where you do all your IP address configurations, and most of us just copied whatever addresses in subnet mask and default gateways given to us by an administrator or a colleague, and really didn't know what those numbers really meant. But this video today will explain what an IP address is and how they work. An IP address is typically a number separated by dots, and whenever we talk about IP addresses, three information that go hand in hand are IP address, subnet mask, and gateway. Like you saw on the previous screen, the gateway is sometimes also called as a router. An IP address consists of 4 octets. Now you might ask, what is an octet? An octet is nothing but a group of 8 So you might ask, what group of 8? To understand that, we need to understand what an IP address really is. To a computer and to all the network devices, an IP address is seen like this. This is nothing but binary representation of the IP address. But since humans like you and I do not have the capacity to remember a number like this, it is made easy for us by converting these binary numbers to a decimal form like this. So this form of representation of the IP address is called as the dotted decimal representation. So it is nothing but the binary octets here on the screen are converted to the respective decimal number. So you might ask, how do they do that? Well, it's very easy. There are different ways of converting binary numbers to decimal numbers, but the easiest way is to have a table like you see on the top of your screens. It's a 8-column table starting from 1 from the right. It goes to 2, you keep doubling it, 4, 8, 16, 32, 64 and 128. Now take one of these octets. So let's assume we take the first octet, which is nothing but 11000000 and put it here. So if you put one bit at a time and you put all those bits here, you would get something like this. Now wherever there is a 1, take the number above that and add. So in this case you just add 128 and 64. So 128 plus 64 is 192. So we could replace this 11000000 to 192, which is nothing but a decimal representation of that number, and it's a much easier number for us to remember. Similarly, we could convert the next octet, that is 101010000, which is nothing but if you add 128 plus 32 plus 8. So 128 plus 32 plus 8 is nothing but 168, and we can represent this octet as 168. Similarly, if you follow the same procedure, you could convert all these numbers to their decimal equivalent. So an IP address is 4 octets long. So as we already saw, you have 4 octets separated by a dot. IP address is also a 32-bit number. So as we saw, you have 32 bits in every IP address. So every octet is 8. So 1, 2, 3, 4, 5, 6, 7, 8, 8 bits into 4. So it's a 32-bit address. Alright, next it says IP address can take numbers from 0 to 255. So you might ask, 255, where does that number come from? Well, if you look at the table again, if all the bits in the octets are 0, the decimal number is a 0. If all the bits in the octet are 1s, the decimal number is 255. So each of these octets can take values from 0 or the maximum 255. If you see a number in the IP address which is more than 255, that's an invalid IP address. Next, we deal with the host and network concept. Every IP address has two information. It has a network field and it has a host field. How do you identify which part of the IP address is a network part and which part is the host part? Well, we do that with the help of subnet mask. So if you see on the screen, the subnet mask will always be a series of 1 followed by a series of zeros. So if you look at the subnet mask, the transition from 1s to zeros happen at the place which separates the network part and the host part. So in this example, 192.168.100 is the network bit. So let me just take another color. Alright, so in this case, this is the network part and this is the host part. So in this case, IP addresses from 192.168.100.0 to 100.255 is one big network. To understand this, let's assume that I'm in New York today and I'm staying at the Hilton. So I call a friend of mine who is also in New York that day and I tell him to come and see me. So I phone him and I tell him that I'm at the Hilton in room number 2014, since it's 2014, room number 2014. And since he's also new to New York, I tell him that the Hilton is on the 6th Avenue between street 53 and 54. Now, if you compare it to an IP address, the address of the hotel is the network part and the room number is the host part. Now, when I told him that, he tells me that there is a very nice restaurant near his hotel, and I must instead go to downtown where he's staying. He's staying at the Marriott in downtown, and there's a beautiful restaurant called the Liberty View across the street, and he said, let's go for lunch there. Now, when he tells me that I need to go to Marriott, one thing I know that Marriott is not in Hilton. So I know that for me to reach Marriott, I need to exit through my main gate. So similarly, if an IP address is not part of the same network, you can know that by comparing the network bit. So if it's a different network bit, it is like it's a different hotel. So like in the hotel's analogy, for me to exit the hotel and go to a different hotel, I need to exit through the main gate. Similarly, if an IP address has to communicate with another network IP address, it has to go through the gateway. So in this case, the gateway is 192.168.100.1. So always remember, the IP address and the gateway needs to be in the same network. If this change, then the network is not valid. Next is the classes. So to look at that, we look at this slide. IP addresses have different classes. A class of an IP address is decided by the first octet. So let's assume the first octet of the IP address is between 1 and 126. In that case, it is a class A IP address. If the first octet is between 128 to 191, it is class B IP address. If the first octet is between 192 and 223, it is class C, and between 224 and 239, it is class D, 240 and 255, it is class E. For all practical purposes and for the scope of CCNA, we would be only dealing with class A, B and class C. Class D is used for multicast and class E is reserved for experimental purposes. If you see, we skipped one number between class A and class B, that's 127. So any IP address starting with 127 is a loopback IP address. So 127 is used for loopback. Right, let's look at class C IP address. If you remember from the previous slide, the class of an IP address is decided by the first octet. So in this case, it's 192. If you look at this table, 192 is class C. So this is a class C IP address. We spoke about subnet mask deciding between network and hosts, but I'm sure you must have asked, how do we know what the subnet mask is? Well, subnet mask is decided by the class. So for a class C IP address, the subnet mask is 255.255.255.0. So if you represent the subnet mask in binary form, it would be this. And like we already know, this separation separates the network and the host bit. So in this case, 192.168.100 is the network part and 225 is the host part. Another way of representing this IP address is by putting a slash. So when I say 192.168.100.225/24, it means that the subnet mask has 24 ones. So 24 ones is nothing but class C IP address. Also, when the host is 0, that is the first IP address in the network, it is called the network ID. And if the host bit goes to all ones, that is 255, it becomes the broadcast ID. So in this case, 192.168.100.0 is the network ID, and 192.168.100.255, which is the last IP in this network, is the broadcast ID. So valid IP addresses in this network are from 1 to 254. So to know how many valid IP addresses are there in this network, we use the formula 2 to the power number of host bits. So in this case, number of host bits are the number of zeros, and in this case it is 8. So 2 to the power 8 minus 2 is nothing but 254 host or valid rooms in the case of the hotel analogy. So if you take the hotel analogy, it is like a hotel with 254 rooms. So this is room number 225. So if there is another room called 226, we can communicate with each other because they're all part of the same building. Also remember, like we discussed earlier, the gateway has to be part of the same network or same hotel in our hotel analogy. So if the gateway is 192.168.99.1 or 102.1, this will not work. The IP address and the gateway should have the same network. Alright, now let's look at class B. Class B, again, if you look at the first octet of the IP address, it's 172. And from the table we know 172 is a class B IP address. So class B IP address will have a subnet mask of 255.255.0.0. If you remember from class C had 3 255s, but class B has 2 255. So if we convert the subnet mask into the binary form, this is how it looks. And like we discussed earlier, this is represented as /16 because it has 16 ones. And again, like we already know, the separation happens here. So 172.123 is the network bit and 100.225 is the host bit. So the network ID is nothing but making the host ID 0. So 172.123.0.0 is the network ID, and the broadcast ID is by making the host bits all ones. So broadcast ID is nothing but 172.123.255.255. Valid IPs are between 172.123.0.0 to 172.123.255.254. How do we know how many IP addresses are there that's valid? We use the same formula. So number of host bits are 16. So 2 to the power 16 minus 2 is 65,534. Now that's a very, very big number. So if you go with the hotel analogy, we see that To have 65,534 rooms, it is going to be very difficult to manage. And that is exactly why we have a concept called subnetting, which is nothing but taking a massive network and breaking it into smaller manageable forms. Cisco says the ideal number of hosts per network should not be more than 500, because they say anything more than 500, the broadcast traffic is going to be so massive that the network is going to be very, very inefficient. So that's why we use subnetting, and we break this massive network into smaller segments. We will learn about subnetting in detail in the next video, but I'm just giving you a heads up of the reason we need subnetting. Now we go to class A. Again, with the same rule, we look at the first octet and we see it is 100, and we know 100 is part of class A. So class A will have a subnet mask of 255. If you remember, class B had 255.255 and class C had 255, 255, 255. So class A has only one 255. The first octet is 255, and if you convert it into binary, it looks something like this. So as we know from what we know so far, this will be the separation between network and host. So anything with 100 is part of this network, and this is also represented as /8 network because it has 8 bits as ones in the subnet mask. Again, if you look at the network ID, which is nothing but making all the network bits in the IP address as zeros, so in this case it's 100.0.0.0 as the first IP address of this network, and the broadcast ID is nothing but making all the host bits as ones. So it is 100.255.255.255 is the broadcast ID. Valid IPs are between 100.0.0.1 to 100.255.255.254. So if you know it, the IP address will go from 100.0.0.1 to 0.2, 0.3, 0.4. It goes up to 0.255, and then it will carry over, so it will become 100.0.1.0, then it'll become 1.1, 1.2, 1.3, 1.4, will go up to 1.255. Again, 1 will get carried over, so it'll become 2.0, 2.1, 2.2, 2.3, and it goes on and on until it becomes 255.255.254. To know how many valid IP addresses are there in this range, we use the same formula. The number of zeros, so 2 to the power number of 0, which is nothing but 200, which is nothing but 2 to the power 24, minus 2 to deduct this first and the last IP, and we get a number 2,097,150, which is nothing but a massive network. Well, even if you compare it with our hotel analogy, it is absolutely impossible to control a hotel of this size. So similarly, if to control a network of this size, having 2,097,150 devices or hosts, it is very, very inefficient, and that is exactly why we will use subnet, like you will see in the next video. So again, gateway will be anything with 100, and only if it is part of the same network it can communicate to the gateway. And like we already discussed, gateway is used to go to a different network. So if this IP address 100 dot something needs to go to another address called 99 dot something, it has to first communicate the gateway, and the gateway, using routers and other devices in between, will route the packet to 99 dot something address. We will learn about routers in the latest part of the series, but remember, if you have to communicate with a different IP address, you have to go through the gateway. Like our example of the hotel, that when I had to go out of my hotel to visit my friend who's in a different hotel, I had to exit through my main gate, and my main gate is part of my hotel, and that is why the gateway also needs to be part of the same network. I think that makes sense, and that's a lot of information. I'm sure I have tried to put it very simple. But you can always write into me, or you can comment on the section below if you have any doubts, and we can always discuss. And I'm expecting a lot of questions for this video, because let's be honest, IP address is easy, but it's not straightforward. I mean, it is confusing, but once you get the concepts right, it's very easy. You can do almost everything in your mind. Right, now it's the time to test your knowledge. Look at this IP address and look at that gateway, and I want all of y'all to take 5 seconds, 10 seconds. You can pause this video and tell me if it is valid. Look at the gateway. Maybe the gateway is wrong, or maybe the IP address itself is wrong. Have a look and tell if it is valid. So how do we do that? I'm hoping that you already paused and you have an answer in your mind, but let me explain how to do it. First we look at the first octet. So we see 133, and 133 is class B. If it is class B, this is the division. So if this is the division, this part has to be same with the gateway. Is it same with the gateway? No, the gateway is in a different network, so it is wrong. So if you see, this is the first ID, this is the last ID, or the network ID and the broadcast ID, and the valid IP addresses are between these ranges. But our gateway is wrong and it is not valid. Brilliant. Now let's look at another example. 192.168.100.315, 192.168.100.1. Pause this video and let me know if it is valid. 192 is a class C IP address. Very good. If it is class C IP address, the division is here. So is it same? If you check, 192.168.100 is same, so that's all right. But is this a valid host? What did I say? IP addresses can take from 0 to 255, but this 315 is not a valid IP address. I'm sure you didn't catch. I'm sure most of y'all didn't catch that. Right, I think that's about all the information I wanted to share in this video. Go through this cloud map and see if you understood all the concepts mentioned here. Please feel free to watch this video as many times as you want. And like I mentioned, if this video helped you, or if any of these videos helped you, please do not forget to share it with your social media contacts, social media platforms, and please like our video, subscribe to our YouTube channel, and the more activities you do on our video channel, it will promote our video and a lot of people will get benefited. If you have any doubts, like I mentioned, do not hesitate to write into me. I would prefer if you comment on this comment section below, because it's going to help a lot of people who come in, and if they have the same doubts, instead of me having to reply to the same query, I could answer that query once in the comment section and all the people can just read it. So have a nice day. Happy New Year once again to all of y'all, and thank you so much for watching. Bye bye.